Welcome to the new Cyber Frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's new Cyber Frontier.
Welcome back to the new Cyber Frontier, everyone. My name is Sean Murray. We've got a couple of great guests all the way down from Arizona State University. We're going to welcome Samantha, Janko, and James Nelson. They are both directors at the ASU Laboratory for Energy and Power Solutions, otherwise known as LEAPS. Welcome, both of you. Great. It looks like a sunny blue sky back there. I see the ASU water tower. So tell us a little bit about yourself.
Yeah, sure. I guess I'll start. My name is Sam. So as mentioned, I'm a managing director over at the Laboratory for Energy and Power Solutions. I have a background in robotics, and then I kind of moved into the energy sector after I kind of fell in love with how interdisciplinary it is and how many different types of people you get to work with when you work with energy. Energy is a part of all of our lives in some form, and it also provides great opportunity for innovation. So I'm happy to be in that space. I recently completed my PhD in energy control systems and considering how artificial intelligence can play a role in that. And nowadays, I am working with LEAPS to engage not only in grid modernization efforts, but also in workforce development efforts.
Excellent. So you've got a great big brain. That's a lot of energy.
That's a way to put it.
Well, great. Thanks for that contribution, Sam. How about you, James?
Right, so I'm James Nelson. I'm also a recent graduate of ASU with my PhD in systems engineering, where I research controls for microgrids and distributed energy systems and really figured out the value propositions they could offer in an economic sense and a resilient sense to a variety of customer segments. Now at LEAPS, I work primarily in grid modernization, where we facilitate with the Department of Defense to provide energy solutions for installations domestically and overseas at forward operating bases. We're working on commercializing technology to provide controls for these systems and also planning and design of these systems. So how we can actually integrate them, provide value for not just the owner, but also the market as a whole. So really excited to be here to talk to you today.
Yeah, we're excited to have you on the show as well. So cyber or information security, right? That's the old, boring term. Cybersecurity is the new sexy term. It really is all about information and those systems that generate data into information and how they communicate. And so in the energy sector, this is one of those industries that we don't hear a lot about. So it's great to have both of you on the show, actually talking about, the perspectives of information and cybersecurity. Both have a strong technical background, it seems, in various disciplines. And so, one of the things that we're going to talk about today from an energy perspective is we're going to look at disruptive technologies in the energy sector. I mean, things are, there's a lot of initiatives worldwide on organizations that in countries that want to go 100% natural energy. What does that look like? What are the systems that are in place? We have old, antiquated industrial control systems for some of our legacy stuff. Wind turbines, solar. James, you had mentioned a distributed architecture that you're going to talk about, and then transitive energy. All just really cool buzzwords that I can't wait to drill down into. So what is it that you want the world or our folks in the United States to know about cybersecurity in the energy sector? What keeps you up at night?
I can hop in first here and just kind of describe a little bit about my perspective and why this keeps me up at night. As you mentioned, we have a traditional, at least here in the United States, we have a traditional grid system in place. It's aging infrastructure that has this weird, awkward teenage stage of development where now we've got this series of Internet of Things technology being placed kind of on top of existing infrastructure. And then as things start to die off and we start to replace, we have new technology that actually physically comes in and replaces that. And what I think we're seeing, and James can comment on this too, is kind of this transition from a one-way street to a bidirectional street. We have generation, transmission, and distribution of power from like a centralized place and then spread out. And now we're seeing everybody interested in alternative energy and what we call distributed energy resources, which includes storage, battery storage, and other types of energy storage, and then solar, wind, all of the classic types of alternative energy systems that you might be familiar with. And those are all just becoming integrated on this large scale without all of the sometimes without all of the thought that needs to be put into it when transitioning from this legacy setup to a more complex, modernized setup. You're increasing the number of digital entry points into your system. You're creating more basically more places that can be that the system can be accessed from, and then also increasing connectivity between those access points for you to bump from one to the next, and just the speed at which everybody wants to be migrating from centralized to decentralized is going quite quick without the standards in place that I think need to be there in order to make sure that we're not leaving vulnerabilities. James, did you want to comment on anything there?
That was great. I think the only thing I can add is that some of the motivation for this distributed architecture is not only for environmental impacts and economic impacts. We have lower cost energy distributed, lower carbon intensive energy when it's solar and batteries and wind turbines, but also resilient. And so that's a really big buzzword in our industry right now, is that adapt to changes, whether it be natural disasters or physical attacks or any other thing, so it can actually have less points of failure because it's more redundant. But if we're these more interconnection, we're actually increasing the vulnerabilities in terms of cybersecurity. And so if we don't actually consider that, we could actually be detrimenting our system instead of actually providing more resilience. And so it's very important. I think really keeps me up at night is like we have the best intentions at heart, but we could actually be causing additional failures or modes of failures.
Yeah, the brains of scientists and engineers, the leaps and bounds, right? So creating technologies and capabilities that are beneficial for the community, but at the same time, changing the culture and making sure that there is a mindset of considering security in that perspective, in that design. Even if you're updating or integrating legacy technologies, it just needs to be considered on the forefront. So great conversation, great intros from Sam and James. We're going to break for a word from our sponsor, and we'll be right back.
Cyber Resilience Institute helps build strong cyber communities designed to prevent members from attack. Like building a neighborhood watch, it takes coordination and a sharing community to protect our identities and valuables in the virtual world. Typically, we hear that organizations know they need to do something to protect their cyber assets, but don't know where to begin. Let Cyber Resilience Institute help your community create an action plan. Cyber Resilience Institute will build your community or business marketplace so that it is designed to support a collective cyber defense. Contact them for more information at cyberresilienceinstitute.org.
Welcome back, everybody, to the new Cyber Frontier. My name is Sean Murray. We've got Sam and James all the way down from ASU. We're talking about cybersecurity in the energy sector. We're talking about the new technologies integrating with old technologies, integrating with other capabilities, communication systems, and we're talking about the risk associated with that. James, you hit it really well on not just from a cyber perspective, but from a business continuity, disaster recovery perspective. So when you can tie that into an organization's, BCM, DRP, and BCP, business continuity planning, disaster recovery planning, and you start tying it in there, you're going to get more visibility and identify the risks that then go to that risk board, right? Identify your stakeholders. And then all of a sudden people are going like, wow, this cyber stuff is really, like killing me, but it's tied back into other business processes. And that's what's really interesting, but it's also really important. So good tie into business continuity. So you said distributed architecture, James. Why don't you elaborate on that a little bit more? We talked about some of the technologies, but talk about distributed architecture. What does that look like really?
Perfect. Yeah. And so our team works primarily in microgrids. And if you think about the term microgrid, really just the main electric grid miniaturized. And so we have the same operational principles as the larger electric grid, but on a small scale, whether that be for a single building or an aggregation of buildings. And so when we have this distributed architecture, so a bunch of small microgrids that can contribute to a larger grid, it's really a bunch of different processes happening on a smaller scale. And so when we actually design these systems, when we integrate them, when we actually build them, one of the hardest parts that I've found is actually the networking of the systems. And so we have a bunch of different assets, whether it be batteries, solar, wind turbines, loads that all need to have data streams either go to them or getting received from a centralized controller. And actually understanding how to network those correctly is a big headache for a lot of projects. It's really like we talked about. They know how they want to size a system, design it, then to actually make it interoperable is a big deal. And so the decentralized network of that is within microgrids itself, because there's a lot of smaller energy assets. And then in terms of a larger grid, a lot of microgrids and other distributed energy assets that aren't very aligned with the old paradigm of centralized generation, where you see larger power plants, natural gas power plants, where there's maybe 10 of those on a region of the grid, where we can have 20 to 50 microgrids. And so just increasing the complexity exponentially.
All right. Well, so that's a great description in entertaining all of the different types of technology that needs to be considered. Sam, jumping back to you. So we understand pervasive technology, disruptive technology. James gave a great description of distributed architecture and how it all ties together. What is LEAPS about? What's LEAPS' contribution to recognizing the requirements, recognizing the challenges, and integrating cybersecurity?
Yeah, sure. So I think that one thing that our team does really, really well is everything that we work on, whatever project that is, it really takes a holistic perspective and tries to involve a lot of different industry groups as a part of the conversation. And then also we really focus on needs-based projects. We want to make sure that what we're creating has an impact, and that like I said before, all parties are included in creating that needs statement, and also making sure that the innovation we're creating is relevant. Does that kind of describe that? I think that we're really just a holistic kind of group, and we have engineers that work with us, sustainability experts, cybersecurity groups. And we kind of just try to cover the whole gamut, so that we're putting the cybersecurity thought up front rather than making it an afterthought like some other innovative technologies may be doing.
Can you elaborate on any of your successes, maybe a project or a program you guys are on?
Yeah, maybe if I could interject real quick. I think Sam's very correct that we have it as an initial design principle in our projects. I also think what differentiates us is that we think about the human aspect as well. So a major contribution to our group is we have a workforce development. And so we're training people to have these. So not only our team is actually thinking about these cybersecurity risks, but then we actually permeate that throughout the industry. And so Sam's actually leading a couple different cybersecurity training programs. Maybe you could elaborate on those.
Yeah, sure. And I think I'll take, before I enter into that, I'll take a little bit of a step back and mention too that I think one of the things that we talked about earlier is what keeps us up at night. One of the things that keeps me up at night that I forgot to mention is just how large the human component is in energy systems, and how it's becoming an increasingly important component, especially when you consider the difference between, information technology and operational technology. In the energy space, we focus on operational technology a little bit more than some other industries do. And there's a big human component to operational technology. There's human interface happening on a greater scale within operational technology. So our workforce development programs kind of focus on giving people, again, that sort of holistic perspective of energy, and helping them understand that that it's a complex field with a lot of interdisciplinary pieces to it. We have about 8 or 9 training programs now in the energy space, and we're stepping into having about 6 programs in the cybersecurity space, with 2 of them focused on operational technology. We primarily teach and train military veterans. ASU has a very large student veteran population, both in person and in online classes. And then we've kind of spread out to also include industry professionals, other academic institutions, lots of DoD defense groups. And then in this more recent cybersecurity initiative for training, we've actually started focusing on ROTC groups and then active duty military as well to kind of prepare them for careers in cybersecurity and then also at the nexus between cybersecurity and energy.
Oh, so there's a workforce development component to the initiatives you guys are pressing as well. So that's awesome. It's a part of any academic institution's requirements on the back end of receiving a degree program. But it sounds like you guys are taking it to the next level where you're actually looking at aligning careers in specific industries to include the energy sector. What type of influence do you have outside? So you talked about the military, the government. What other institutions or government agencies are interested in what you're doing or are you collaborating with?
Well, I think for the workforce development side, we've primarily been focusing on work with the Navy, the Office of Naval Research, and we've started to spread out into work with the Department of Defense as a whole. I think that's actually where we pretty much live, is within the Department of Defense space.
Yeah, so more recently we have a lot of our funding and partnerships with Department of Defense, but previously, probably 3 years ago, we had over 50% of our partnerships and projects with industry, people within the industry, including local utilities, SRP, APS, and having the innovations coming out of ASU be directly applicable to our local environment. We also work with some of the national labs, NREL. We're actually doing testing out there later this year or early next year about a new technology and doing a cyber security check on a new controller being introduced to the market for industrial control for microgrids. And so we really facilitate with them. And then there's a couple groups out in Hawaii, the Hawaii HNEI, Alaska. We work with the Fairbanks, Alaska, University of Alaska Fairbanks. And so academia, industry, local utilities, really anybody that has a passion for industry and security, facilitate it.
Okay, well, great. So, you guys aren't working all by yourselves out there. And it really is key for collaboration. We usually don't hear cybersecurity in the energy sector. So anytime we see those collaborations going on, it just provides more value to the community overall. James, you had mentioned industrial control systems. So, this is one of the big focus areas, it seems, in the last couple of years, manufacturing, utilities, and, other areas, telecommunications, our grids, our power grids. There's a lot of legacy technology out there. There's a Polish researcher over the last year who wrote a script that's on GitHub now, and he did an overlay with Shodan, for example, and he started it in Eastern Europe, showing all the industrial control systems that were wide open. You could log into them, or you don't even have to log into them because they're not even protected. Then he did an overlay and showed with Google Maps and showed on where they were in Europe, and now he's done it here in the United States. So, what do we do? What did we do to recognize where we have weaknesses in industrial control systems, and what's your perspective? How do we address those issues?
Yeah, I think how we do it is that we design some of our own control systems. And so having that cybersecurity mindset in the beginning is essential, but obviously we're not the only players in this market by any means. And so we'd like to do a lot of collaboration. One collaboration I forgot with is Nywick, and they're located out of San Diego. And they actually have a whole team that does evaluations of industrial control systems and available technologies, specifically on defense application installations. And so they have like a consumer report that they provide to the defense industry about the vulnerabilities that you would see in these industrial control systems. So I think maybe be able to translate that into more of a private sector or open source even would be very beneficial. So people can understand the vulnerabilities and potentially mitigate them before an attack actually happens.
If I might mention something there, It is great to have open source things and being able to communicate and chat about these issues. But of course, the more open source you get, the more you're revealing to potential adversaries that you have these ideas and these protections in place. So it's interesting that I like to think about cybersecurity as it's kind of a moving target, in that, the vulnerabilities are not static. Every time somebody learns something new about your system, because maybe you shared it or maybe they exploited it in some way, you also have to make sure that your risk mitigation is moving with that target. I think that's definitely a key point there, that every time you have a new piece to your system installed, or if you're a utility looking at your system trying to figure out what you can do to help, secure your ICS, it's kind of like, you need to make sure you understand your local system and what you're adding to it has now changed your entire network, just by one point, or making sure that you have identified that your new vulnerabilities that may have come into play when you install your new equipment or have changed your equipment.
Yeah, great points. Yeah, that's a great place to stop for a short break. We're going to come right back with Sam and James from ASU right after this break. Welcome back, everybody. I am Sean Murray to the new cyber frontier. We've got Samantha, Janko, and James Nelson from Arizona State University. We've been having a great conversation regarding the energy sector and the contributions that they've got with their organization. They've graduated from various programs at ASU, and now they've been working for a few years. Contributing back to introducing a cybersecurity strategy in the energy sector, in the energy space. And so, we've discussed disruptors. We've looked at different types of energy utilities. We've taken a look at Internet of Things and industrial control systems. Talk about transitive energy. That's one of the buzzwords you guys came up with prior to the start of the show. What is transitive energy?
Oh, sure. It's actually called transactive energy.
Transactive
and
energy.
Yes, transactive energy, and you're so right that it is a buzzword. It's been, in the last few years, it's been an exciting topic for researchers as well as technology vendors. It really focuses on how can we make control of a power system, or energy transactions, kind of be controlled by markets and by economics, and having value attributed to the actual controls that are happening. I think this is actually an interesting topic to talk about, both from an inside of a system perspective, which James can comment on, and then external to a system perspective, which I can comment on. My research in the past has focused on how artificial intelligence plays a role in how the future power systems of the world can be controlled, and transactive energy plays a big role in that. So James mentioned that we as a group focus on microgrids a lot, and if you're not familiar, a microgrid is just a small scale energy system that can connect or disconnect from other energy systems at will. And if you start to consider that multiple of these systems are starting to just appear all over the map, how can they actually communicate and work together towards common goals? Instead of by adding more to your system, you could be increasing vulnerabilities by having more points of entry, but you can also collaborate and work together. There's been in order to observe your system better, actually, and to support it better from the perspective of cybersecurity. One common example of that is the Brooklyn microgrid, which is out in Brooklyn, and they have focused on how you can use blockchain actually in this way to kind of watch your network, using multiple points of observation and being able to verify transactions that happen if you're trading energy between systems, based on those transactive energy concepts of, okay, like if it's a market price that's actually causing me to send power this way because somebody has accepted that I'm going to buy power at this price, we can actually make sure that that transaction is verified. And that type of transactive energy process also happens on the internal level, which I think James can comment on a little bit. That these pricing schemes can also control how individual assets act, as well as the larger system.
Right. So internally, we typically consumers of the electric grid are just are there's one direction, and so they're typically only consuming electricity at any given time. Now with transactive energy, those consumers turn into prosumers, where they can actually produce electricity with distributed energy resources like solar or batteries or wind turbines. And so now it's a bidirectional exchange. And so with that bidirectional exchange, there's additional economic incentives to actually participate at a larger scale. And so typically utilities have natural monopolies in certain regions. And so they set the rules and they're regulated by government agencies within that region. And so now it's becoming more unregulated and more competitive for consumers. And so instead of just going to the supermarket and knowing that you have to buy it from a certain supermarket at all times, you can go to your neighbors and buy electricity from them. And so you can understand what you have locally in terms of your own generation and your own needs. And then you can go to your neighbors and shop around and say, all right, what's a lower cost? What's more local to me? And that's really about transactive energy and how we have more options and makes the marketplace more competitive.
Oh, that's awesome. And, it's interesting. I've got a friend who just spent a lot of money putting solar into his property, and he's got these two huge white boxes in his garage, to the point where he's actually selling the energy back to the utility company. And they actually use it because it's utilities are actually balanced out. So it's a municipal. So all the utilities are part of his bill. It actually averages out and reduces the cost of his other utilities, as well as water, his wastewater, and some of the and his gas. So that's pretty interesting as well. For cybersecurity, energy sector, where do you see us in the next couple of years? Hopefully we're changing the culture. We're building cyber into our newer technologies. We still have issues and concerns with solar flares. Goes back to James's resiliency comment. How are we addressing these bigger issues and making sure that we maintain a cyber focus?
Did you want me to hop in, James, or would you like to?
Yeah, go ahead.
Sure. I am always a proponent of including the human side of the problem. So I see, in the next 10, 15 years or so, really promoting awareness and education of cyber within our culture that we're creating, and also improving the understanding that operational technology is different from information technology, and that we have to think about things differently, because a cyber attack is doing more than just data acquisition at that point. It's also affecting physical systems that can have a cascading failure effect. And I think understanding that humans play a role in both IT and OT, and also increasing the number of cybersecurity professionals in that space that have that understanding, and also understand the entire, having a system view of individual energy systems, and seeing where those pieces interconnect in order to build a better defense. I'd like to see that in the next 10, 15 years.
And then if I could add a couple of thoughts, by no means it's all encompassing, but I think in the next 5 to 10 to 15 years, you'll see a lot more blockchain come out whilst transactive energy increases in popularity, because you have that immutable history of what's happening. And so you have a ledger of all the transactions to make sure that your system's operating technically stable, but then also economically in a fashion that's fair and competitive for everybody in the marketplace. Also ingraining cyber security and network security into industrial control systems. And so not only understanding how they operate once you install them, but the supply chain of those industrial control systems when they get to your site, making sure that they're stable and secure through the full supply chain process, and there's no malicious behavior, and you can actually track that. And so I think blockchain actually can be used for both of those applications. And there's obviously a variety of other network security aspects and considerations to be made during the operations of these new technologies as well.
Yeah, great contributions from both of you. We're getting towards the end of the segment. It's been a great conversation regarding the different types of technology, the different perspectives of how we secure it, especially as we evolve. What closing remarks, what do you want our listeners to take away from this segment today?
I would honestly say that, again, I'm always a proponent of education. I would say educate yourself about the energy systems that exist around you. There's so many people that I meet that don't know how power gets to their outlet. And really, if you're interested in cybersecurity and you're interested in learning about how it integrates with energy, or the two fields meet up, it's really important to also understand the changes that the energy sector is going through right now, and the types of vulnerabilities that will open up. And it all starts with understanding, the basics of energy transmission and distribution, and then also understanding that across the world there's many different ways in which that is happening. And top down orders of, oh, we need to have solar and we need to have storage and we need to add these things can create rush jobs that sometimes don't put as much thought into the cyber piece as they should. I would recommend educating yourself.
Okay.
I would definitely echo Sam as well. I mean, knowledge is power. And so having the more knowledge of not only the energy landscape, but also the cybersecurity landscape and where there's intersect will give you a lot more power in making decisions when designing systems, when operating systems. And so really just making sure that you're aware of the best practices in the industry, what those standards are, is essential to ensure that we have a safe and secure utility and electrical infrastructure for years to come.
Yeah, and part of that is communication too, right? Getting in front of the right people, communicating that, articulating that, changing the culture of those who can influence, decision makers. So it's a great discussion. I wish we had more time, but I'd like to say thank you to Samantha Janko and James Nelson from Arizona State University. Appreciate your contribution to the show this afternoon. One of those unique topics that we're going to continue to have those discussions on. So thank you once again. This is Sean Murray with the New Cyber Frontier. This is it for this segment, and we wish you both very well.
Thank you so much.
Thanks, guys.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.